Welcome, my little triglets. We are moving onward and upward. Section 3.3. This is going to be about angular and linear velocity. A little bit of physics, but don't be scared. It's not so bad. Just a couple of formulas you got to know. Angular and linear velocity has to do with anything that has rotary motion going round and round, like gears or wheels or Ferris wheels, anything going round and round. So, the first one we're going to talk about is angular. Angular velocity is basically how fast the angle is being formed. How fast the angle is being formed. So the formula is W for angular velocity equals the angle divided by the amount of time. So this is the angle, theta, and of course t is the time it takes to make that angle. Now when you talk about angular velocity, you use labels such as revolutions per minute, or radians per second, or rotations per second. Any of those are considered going round and round. Revolution, radian, and rotation are all round and round. Now if you notice, all three of them start with the letter R. And for our purposes, we're always going to use one of those three. So to help remember or help realize what form the number is it angular or is it linear, you can look at the label. And if the label starts with R, I try to think of it as angular. Angular velocity has R for the units. So I know it's not the most scientific way to remember or to figure it out, but it does work. All right, so let's try a quick question with angular velocity. And let's say we have a second hand on a clock. Second hand goes around 60 seconds. So we have a second hand. And I want to know its angular velocity. And if that's all the information that I give you, you have to do some detective work here. So second hand on a clock, we know it takes 60 seconds to go around. And one revolution, one trip around, is 360 degrees, or 2 pi radians. So if we want to find the angular velocity, we should use this one. Mostly because you can't use degrees in formulas, but also because it's got the R there for angular. So theta over t would be 2 pi over 60 seconds. And this is radians, this is seconds. So when you divide, you should get about 0.1, and then your label is radians per second. So just, you have to think a little bit. If they don't give you much information, but it's like a clock, then you can come up with your own numbers. Now linear velocity is a little bit different. Linear velocity has to do with how you move in a straight line. When you run track, you run meters. When you're in a car, you drive miles. So linear velocity is actually the distance traveled per time t. So the linear velocity formula, they use capital V. V equals the distance, which is going to be the arc length, divided by t. Okay, this is distance or arc. And then this is time. Now we have, remember the SOAR formula, S equals theta r? Well, S equals theta r, I could put theta r in place of S, so this formula could be theta r over t. So those are two versions of the same formula. It just depends what they give you in the problem, which one you're going to choose. So let's try a problem and see which one would work best for us. So next page. So I have, let's use that same second hand. And the only difference is I'm going to tell you that the radius of the second hand is 8 centimeters long. So I want to find linear velocity. So what else do we know about the second hand? Well, like we did before, the angle we can use is one revolution, which would be 2 pi radians. And the time it takes to go 1 revolution is 60 seconds. So we've got r, we've got theta, and we've got t. So we might as well use v equals r theta over t. Putting in what we have, 8 centimeters, theta is 2 pi radians, and time is 60 seconds. So multiplying out, do all that, you should get about 0.84. Now the question is, what do we label this? Well, radians is kind of a strange label. It really isn't part of the label unless it's the only thing there. So for this one, we're going to do centimeters per second. Now if you think of linear velocities, when you talk about measuring something in a straight line, you're going to get centimeters per second, you're going to get miles per hour, you're going to get feet per minute, anything like that. Anything that can be measured in a straight line, feet, miles, centimeters, that's linear. So the radians label drops off unless there's nothing else on the top. Then it stays. It's kind of poor and forgotten sometimes, but we won't forget about it. Now the next thing I want to show you is there's one more formula and it goes like this. Let's recap or review what we just did. V equals r theta over t. Now we also said that W equals theta over t. So we can put that one up there too. And if you notice, each has a theta over t. So I could put this up here and say V equals RW. So notice we have linear and angular in the same formula. So this is to convert from linear to angular or angular to linear. So it's kind of a general formula that combines the two together. All right, that is it for today. Don't forget, give your trig a little bit of love and it will love you right back. Ta-ta.